All right, so I hope that practice went well for you. This one is a lot easier, I promise. There's no math involved. And this is just kind of about those graphs we were looking at before. How are populations actually regulated? What affects whether or not we've reached carrying capacity? What affects the carrying capacity overall? So this is regulation of populations. And there are two types of regulation. So again, I'm going to do my paper in half there. So two types of regulation. The first one is called density dependent. And the second one is called density independent. Okay, so density dependent regulation. What that means is the more dense a population gets, the less resources they're going to have per organism. Okay, so if you've ever had, like a gathering at your house where you have food and then more and more people come and this person brought their friend and that person brought their cousin and their brother, then you're going to have less food per person, right? The more dense your house gets with people, the less resources you have. Okay. So what would that look like? What are some of those resources that we could run out of? Okay, so we could run out of food, shelter, water. All right, another density dependent factor, predators. If there is a very small population of rabbits, well then the predators don't have many to get, maybe they're spread out. But if there's a really large population of rabbits, well the predators have an easier time. So they've got more options. And it's easier to get the prey. With a large population, I guess. Something that's happening now is that if you have a large population or a dense population, disease can spread more quickly. So if you've seen graphs of where the coronavirus is, especially in the United States, you can see that it's really highly concentrated in like the Bay Area and LA and in New York, where those places are really dense. They're full of people. People are interacting all the time. But if you look in the middle of the country, like in Iowa or something, people are more spread out anyways. And so the virus isn't really, kind of getting a foothold in there because it's a less dense population. So disease can spread quickly when you have a more dense population, more organisms in the same place. All right, and then for things like, especially like mice, waste accumulation is an important factor. So when there's a ton of mice all in one place, they're all going to the bathroom, it can actually poison their water supply, it can poison their food supply because there's just too many of them in one place, and then it'll start killing off the animals. So these are all things that are going to affect the carrying capacity. Okay, so here's the carrying capacity. As the population gets more and more dense, larger population, things are going to die more because of all these factors above. Once I start getting more and more dense for this population, we're running out of food, we're running out of water, predators are picking us off more easily, disease can spread, things can poison us more easily. Okay, so as the population gets more dense, all of these come into play, and it affects the carrying capacity. Okay, so density independent. What can reduce a population size? If it doesn't matter how dense the population is. Okay, so it's going to reduce the population no matter what. So this would be things that reduce population size. No matter how dense the population is. So mostly, it's pretty easy. Those things are going to be like natural disasters. So things that can reduce the population size, doesn't matter how dense the population is, how many animals are there. So that could be like a fire, a flood, a hurricane, any type of natural disaster. So when we look at that graph, it's going to look a little different than the first one. So they have a carrying capacity. This is the amount of organisms that can live in that area. But if you see a graph that looks more like this, okay, right here was some kind of density independent event. Okay, the population never reached their carrying capacity, but a bunch of them started dying. So that's how we know something else happened. There had to be some other natural disaster, or like hunting could be there. So we are growing exponentially. We did not reach our carrying capacity, and all of a sudden the population declined. So that is some kind of density independent event. It didn't matter that we weren't at carrying capacity. Things started dying. And then after we're going to recover from that event, grow exponentially until we reach carrying capacity. So those are different things that can affect populations.